We've talked about 4 ways to make new functions from old by adding, subtracting, multiplying, and dividing. When we add 2 functions or multiply 2 functions, the order in which we do that doesn't affect the graph that we get. With subtraction and division, though, that does matter. We get different results depending on the order in which we subtract or divide. For all of these functions, remember, the domain of the new function is the overlap of the original function, and in the case of division, we also have to consider or exclude values of x where the denominator is 0. Now there is one more way to create new functions from old, and that's a composition of functions. And I like to say that's like putting one function inside of another. Okay, here's what I mean. I'll demonstrate that with these 2 functions. So a composition looks like this: f of g of x. That's going to be our new function h of x. Okay? And so basically what you're doing is you're taking x, you're applying operation g to it, and then you're taking what you get, operation g, and applying operation f to it. Alright, so let's just break this down. I like to use a bubble approach for this. I'm going to start with x, and then as I said, the first thing I'm going to do is apply g to it, and then I'm going to apply f to g to create my final output. Okay, let's take some specific numbers. So if I were to take 1, I'm saying I'm going to put 1 in for x, and then I'm going to g it. So 1 minus 1 would be 0 as my output for g. Now that I've got g, I'm going to apply operation f to that. So I'm going to do 0 squared, because that's my f function, and my output is 0. So 1 comma 0 is a new point on my new function, which I'll call h. Okay, let's do this again. Let's take 3. So I'm going to take 3, there it is. I'm going to apply operation g to it. 3 minus 1 is 2. I'm now going to take that output 2 and apply f to it. 2 squared is 4. Let's do this in general. Let's take a value x, and if I g it, when I take x and g it, I can see that I get x minus 1. Now I want to take x minus 1 and I want to apply f to it, which means I want to take this and plug it into x here to get x minus 1 squared. And you'll notice that if you do it with a formula, then for any value of x, so for example, if I just want to check 3 to make sure that 4 is correct, if I wanted to use my formula here, I could put my 3 directly in here. 3 minus 1 is 2 squared, and yes, I do get 4. Okay, so that's called a composition of functions, a function within a function. Now let's do the same question, but let's do it with g of f of x. So I'm doing it in a different order. And so again, our functions were f is x squared and g is x minus 1. Alright, this time I'm not going to use the bubble approach. I'm just going to pick some values of x and we're going to work them out. So if I wanted g of f of 1, let's say, I would plug 1 into f. That would be 1 squared, and so that would be 1. And then I'm going to plug that output from the first step into g to get my new output 0. Alright, let's do g of f of 3. So we're going to do f of 3, put 3 into f, and we're going to get 9. We're then going to put 9 into g, and we're going to get 8. And so our output point is 3, 8 on our new graph. You'll notice that we got a different result when we plugged x equals 3 this time than we did before. Okay? In other words, the order in which we compose the two functions matters. Okay? let's do this in general. G of f of x. We're going to take x and apply function f to it. In other words, that's going to be x squared. This is now saying we're going to take x squared and plug it into g. So that would be x squared minus 1. That's the new function in general. And again, we could check this one out. If we plug 3 into there, 3 squared is 9 minus 1. Yes, that does give me 8. All right. Okay, just another example, f of x, g of x, and we want to, now this notation, the little o in the middle, that's code for compositions. So this symbolism isn't multiply, it means f of g of x. Alright, so we want to work f of g of negative 11 out in two ways. So the one way would just be to apply this numerically immediately. I'm going to plug negative 11 in for g. And so that's going to give me negative 10 out. So this all replaces with negative 10. And then I'm going to put that output from g as the input for f. Into this function, the absolute value will be 10. The other way is to get a general formula first. F of g of x. Well, if we take x and g it, we already know what that is. It's x plus 1 because we're told that. And then we want to take x plus 1 and apply f to it. In other words, this is the input for f. That gives us absolute value x plus 1. And now, if we wanted to do f of g of negative 11, we could plug the negative 11 directly into our formula, absolute negative 10, which is 10. Okay, here's another situation. This time we want g of f, that's how you say it, of x, g of f of x. And we want it as a formula because we're asked in terms of x. And then we want the domain of all of the functions. Let's actually do the domain of f and g right now. So on f, it's a square root graph. We know the radicand must be positive. So our domain is x is greater than or equal to 1. And our g of x is a parabola opening down. So x, all real numbers, is our domain here. Now the question is, what's going to be the domain when we compose two functions? With the operations we've talked about so far, it's generally the overlap or the intersection of the two domains, except when you divide, you've got to remember you can't have the denominator being 0. Is the case the same here with composition? Okay, so let's just look at this. So f of x is the input to g. So this has to go in here. And then this needs to go into g. So if I look at the domain of my final result, I can see that certainly the overlap is important when considering the domain. Any value greater than or equal to 1 can be square rooted. Now the question is what comes out of that able to have the next operation applied to it? In this case, squaring. Well, yes, it is. But in some cases, depending on what you're dealing with, that may not be the case. So you need to consider not only that the values of x you're putting in work in the first step, but that what comes out of the first step can work in the next step. So in this case, since that's possible with x is greater than or equal to 1, that is your domain. Notice that even though this expression is reducible to the negative of x minus 1, we need to consider the domain not at the final reduced expression, but before the simplification takes place. Let's just look at what if the question had been the other way around. f of g of x. So g of x would have been put into f. Any value of x was able to go into negative x squared to produce outputs. However, the outputs that we get here, once we minus 1, must also be square rootable. And in that case, actually, nothing is going to work. Doesn't matter what value of x we put in, we're never going to get positive values out of that, and minusing 1 is going to make it a little more negative, and we can't square root negative. So in this case, there would be no graph. Now that's a pretty extreme example, but it demonstrates the point that your domain isn't just the overlap of the two original domains. You have to consider the values of x that produce values of g of x, but also which of those values allow g of x to be inputable into f. And from there, make your final decision. So finding the domain of the composition of two functions can be complex. Final example, we have here a function that's been composed of f and g, and we want to figure out what the original functions f and g might have been. Alright, so the way I like to do this is g of x is our inside function, g of x is inside of, has been put into f. So if I look at the big picture here, I can see that, and there's many ways you could do this question, here's just one. This function is inside of the bigger picture. Okay, so I'm going to call g of x cube root of x, and I'm going to call f of x just x plus 3 over 3 plus x. And I'm doing that because g of x, if I apply this, I would put this in every spot that I see x in here, and that would create for me h.